So in the last, so in this topic, we're going to talk about the Coulomb-Mohr theory, which is used to predict the failure of brittle materials. Um, so for brittle materials, often they don't have much plastic deformation in their stress strain diagrams. So typically, instead of reporting a yield stress like that you would for like a ductile material like a metal, like a aluminum or like a steel alloy, typically you use an ultimate strength. So for certain brittle materials like tool steel, the ultimate strength in tension and compression behaves like the same. So they have the same ultimate strength in tension and the same ultimate strength in compression. While other materials like cast iron, for example, they are sometimes much stronger in compression, sometimes up to 4 times stronger in compression than they would be in tension. So, so due to these different failure modes, so typically for brittle materials in tension, they will fail along the principal stress direction. So, all right, and then for compression materials in compression, they'll typically fail along the plane of maximum shear stress. All right, so um, so what the Coulomb-Mohr theory states is that if you draw a Mohr circle, all right, that it's and you can write its so if you have a Mohr circle and you have a case where you have just pure ultimate pure tension, um, all right, that would be the edge of your Mohr circle, and you could that would be the so this is your ultimate um, tensile strength here, and then on the left hand side you have your ultimate compressive strength right here. So um, so if you drew a case where you had pure compression, you could draw a Mohr circle for this. All right, so this would be if sigma p3 would be equal to the ultimate compressive strength, and then what you could do is you could draw a line that would go tangent from the this Mohr circle here to the ultimate tensile strength, right? Um, and then this would be your bounds for your uh, for your failure criteria. So what you would do is you would draw your Mohr circle for a given state of stress. So let's say you had a state of stress where this was your minimum stress, your sigma p3, and this was your maximum stress, which is your sigma p1. Right, and you drew your 3D Mohr circles. Right. So based off of this, because your Mohr circle, since your 3D Mohr circle is outside of the bounds, you'd have material would fail. Alright? Alright. In the case of when we have simple, if we have our simple principal stress cases that we discussed before, so these are the same as we discussed in, I believe it was topic. So this is the same 6 cases we had in the case of topic 28, where we have our different principal stresses, and we could draw our 3 different cases of our different Mohr circles. So in the case of the Coulomb-Mohr criteria, when we draw our boundaries of our maximum allowable stresses, what we'll do is we'll have um, we'll plot our ultimate tensile strengths along the positive or the tensile axes for sigma p1 and sigma p2. All right, And then for our negative stresses or compressive or negative axis, or for compressive stresses, we'll plot our sigma ultimate compression and our sigma ultimate compression. So what we'll end up getting is we'll get a varying window, or our bounds of our potential of our different stress states for a case of plane stress are going to look like this. Okay, so anything within the bounds of this drawing here would be a case of stress that would not cause failure, and anything outside of this box would be a case that would cause failure to occur for a brittle material. So if you know the ultimate tensile strength, you know the ultimate compressive strength for material, you can create a plot like this, and for any given state of plane stress, you can plot it, and you can determine whether or not failure would be within the the capacity of the material or outside the capacity of the material when it would fail.